Welcome back to another MyTutor online school tutorial. Today, GCSE Maths, and we're looking at the volume and surface area of 3D shapes, mostly focusing on the volume, but we'll touch on surface area. So this session is 1 hour, it will finish at 3 p.m. And this is me, Molly, who's running the session. I just finished my second year studying computer science and maths at the University of Bath, and I've done lots and lots of lessons with MyTutor, and almost 50 of these sessions now. So hopefully that means I know what I'm doing, as I always say. So the structure of this session, ooh, the sun's bright, that will go in a minute, is that we'll do a Kahoot at the beginning, go through all of the different ways to calculate volumes of various shapes, doing lots of practice questions together, and then we'll do another Kahoot at the end, so that you can like test your knowledge at the start and at the end of the lesson and see how it's improved. So let's jump into it. Where's my Kahoot? There it is. There it is. Volumes of 3D shapes. So yeah, this Kahoot is just on the volumes, because that's pretty much what we'll be focusing on today. And I'll explain the exact content that we'll be covering today whilst you guys are joining. So you can either go onto kahoot.it on your phone or your laptop, or there is a Kahoot app as well. So let me just, okay, don't want the Kahoot sound happening. So yeah, the structure of today is basically this. So we're going to first of all have a look at some basic volumes of shapes, so cubes and cuboids, prisms, learn what they are, what we can use for that, and then some specific ones, so cylinders, spheres, and cones. So loads of different shapes that we're going to be looking at, learning a couple of formulae, and doing a lot of practice questions. And for each shape, we'll also do one or probably just one question on the surface area to show you. But as I said, because there's loads of different shapes to cover, this will pretty much just be looking at the volumes. Oh God, I can't remember too. If there are people who are here now who weren't here last week, that might be confusing. So I'll wait until a few more people have joined. Let's do this. Let's can't remember one. So I think there's 3 more of you to join. Just pop a message on the chat or the Q&A if you're not, so that I know when to start. If not, I'll wait for people. Okay, cool. Some people are joining, so I'll just wait. I'll give it till about 5 past, maybe 6 minutes past. So yeah, so this Kahoot starts with, I think there's a couple of formulae, but it's mostly like just questions. What's the volume of this? What's the volume of this? And so on. Gang number 3. Anyone else waiting to join, or shall I get going? Okay, someone else is joining, so that's fine. I'll wait for that one last person and then we'll get started. I'll keep it open throughout anyway. I think there's 7 or 8 questions in this. Okay, cool. Right, let's get started. So if there is anyone else, you can join. It's open. So there are 5 questions. Okay, first one, find the volume of this. Cool. Yeah, the sneaky bit with that was that this says 100 meters squared, and volume is always in meters cubed, or some length cubed. So you did the maths right, you've got to multiply those all together, but that one was sneaky with the units there. Okay. Next one, the volume of this solid. So this is a triangular prism. If you don't know what that means, don't worry. I will be going through what that means and how to calculate volumes of them soon as part of the lesson. Perfect, well done. Yeah. So I'm not going to explain why these ones are. In the final Kahoot, I'll go over them. But for this one, it's just a preliminary kind of check. Again, this is from an American Kahoot, inches. Okay. Cool, well done. So again, most people getting that. That's nice. Well done, guys. Okay, so now we want to know what's the volume of a sphere with a radius of 1 centimeter. So radius of a sphere is from the center point that's like in the middle of it to the outer edge. This is basically just testing whether or not you know the formula. So don't worry if you don't. We're going to be learning that today. It's just one to see here how many people do already know it. Cool. Looks like lots of people do actually, or people are good at guessing. Final question. Now it's about a cone. So a cone with a radius of 5 inches and it's 13 inches tall. So a cone is a circle and then it kind of comes up into a peak. So radius of 5 inches on that circle on the base and 13 inches from the center right up to the peak. They're kind of like these shapes on here, these triangles, but imagine them curved in 3D. Again, this is testing if you know a formula. So don't worry if you don't, just guess something and we'll look at the formula today. I'll let the timer go down because there's one more person still to answer. So I'll give you the 30 more seconds for that if you need it. Perfect, well done. So you guys know these formula well, or maybe spotted because it's between. So for those who put red or green, spot the units here. This is a length, this is a surface or an area. So it had to be between yellow and blue really. So you can narrow them down in that way if you know about units and can spot stuff like that. So well done. Gang member 2 there in third with 4 out of 5. Hey, top 2 got 4 marks as well, gang member 3. And in first, will it be gang member 1? Nah, there you go. Square root minus 1 equals I. Beating the gang members there. Congrats. So yeah, really well done on that. That was a high percentage, 62. So really, really well done. And we'll see. I don't know if we can get higher on the final one. I guess we'll find out. So we're going to start off today quickly going through the basic ones. So cubes and cuboids. So you're going to get a lot of 3D sketches from me today. So we'll see how good they turn out. Oh, that's such a maths teacher trope, isn't it? Oh, I'm not an artist. But so a cube is lots of concentration, where every single side has the same surface area, all of the angles are 90 degrees, and all of the length of those sides are the same. So like if you took a square and put 6 of those squares all together, make a little cube, like a Rubik's Cube or something. And the way that we calculate the area of this is if you just know one side, so this is x, then the volume is just x cubed, because we know that all of those sides, that's also then going to be x, as is that. So you see how these go in 3 different directions. We've got this kind of almost x and y planes flat along the bottom, and then you've got this one that comes sticking up. So you just do each of those multiplied. For the surface area of this, for a cube, it's nice and easy. The surface area of each face is going to be x squared, right? Just by the area of a square. and then we multiply that by 6. So the surface area is 6x squared. So now, whatever size your cube is, you can really, really easily find the volume and the surface area. So the volume, say x was 2, this is a 2 centimetre by 2 centimetre by 2 centimetre cube. Volume, 8 centimetres cubed. Surface area, 24 centimetres squared. So hopefully that makes sense. Let me know if I'm going too fast. I feel like people did well on these beginning bits. Now a cuboid is very, very similar, but a cuboid, they don't all have to be the, oh gosh, that was atrocious. They don't all have to be the same length, as I've tried to demonstrate here. So you can see that we've got it kind of stretched out like this. It's like if you took a rectangle rather than square, so stretch that out. So what we do here, if we label these this time with, say, x, y, and z, then the volume is just x, y, z, centimeters or whatever the unit is, cubed. You just times, as I'm sure you worked out how to do in that one, you times each number by each other. Then for the surface area, we work out each surface, so it's going to be xz, and do that twice for the one at the back, zy, and do that twice for the one at the back, and xy, and do that twice for the one at the back. So if you want a generic formula for the area, that's going to be 2xy plus 2xz plus 2yz. But it's easier just to think about it face by face, as we're going to do for the surface area in each case here. So that's cubes and cuboids. I'm not really, unless you want me to, going to run over any examples of them, because it's just multiplying all of the numbers together. So hopefully those make sense. But feel free to just speak up in the chat or Q&A if you would like me to come back to these. So the next shapes to think about are prisms. Now, the definition of a prism is that we take a 2D shape and we stretch it. So a triangular prism is where you take a triangle and you stretch it. Like a Toblerone is a triangular prism. But you could have anything. You could have, and I'm going to regret this, a hexagonal prism. So we have a hexagon. And that's stretched. You can really see my drawing skills coming into use here, can't you? So that kind of makes sense. Oh God, that's horrendous. Apologies. But the drawing skills don't really matter. Hopefully you get my point, that this is that we've taken a hexagon and we've kind of stretched it out and backwards. Technically, cuboids are rectangular prisms and stuff like that. So you can think about everything in this kind of realm as a prism. Now these have a nice generic formula for how you calculate the volume of them. The way that we're going to do that is that you calculate the area of whatever the face is. So in this case, the area of the triangle or the area of the hexagon. And then you multiply it by the length, L, so how far you stretched that out. So it's kind of, let's call it AL. The area of whatever the 2D shape is at the front times how much you stretched it by. And hopefully that makes sense, because if you've got a triangle of area 4 and you stretch it out 5 times, that's 4 times 5. That's a simplified way of phrasing it, but hopefully that makes sense. So yeah, the volumes here are AL, however you want to think about it. Surface area, fairly simple to think about. You just think about each surface in turn. For example, with a triangular prism, so there's our triangle, make it into a prism. We can think about the area of this triangle and remember that there's an equivalent one at the back. We can use this length and this length to find the area of this rectangle, and remember there's another identical one on the other side. Or it might not be identical. We might, if this length isn't the same as this length. But for argument's sake, we'll say there's an identical one, and then on the you take this length and this length to find the base. Add them all up and it works. So we will go through a couple of surface area questions at the end once I've kind of gone through everything. But I guess the thing, if you're kind of making notes, the key things that I want you to take away from this right now is that the volume of a prism is area of the face times length. Okay, cool. And then we've got cylinders. Sorry, the beginning bit of this is very talky, isn't it? Do let me know if chime in if you want to do some practice questions throughout. Do let me know. So the next one is cylinders. Now the secret with cylinders is they're just circular prisms. You take a circle and you stretch it, you've got a cylinder. So we either see them drawn like this as a kind of long tube, or on its top like this. Hopefully those make sense. Just think of like a toilet roll or something, or a Pringles tube. those are cylindrical shapes. So the way that we find the volume is the same as we do for any prism. We find the area of the top and we multiply it by the length, A times L. Obviously, we just then need to know the formula for finding the area of a circle, which I have covered before. Just a note that the area is pi r squared, where r is the radius of this circle. So just bear that in mind. Surface area is then slightly trickier. And I would say the surface area of a cylinder is probably the hardest one that we're going to do, because you have to, it's not as easy as the other ones, but unlike when we come to a sphere and a cone, it's not just a formula that you can plug in. So the way that we find a surface area, first bit is easy. It's just the top and then an identical one on the bottom. Then we've got to think about this bit that wraps around, like the label on a tin of beans. Well, if you think about that label on a tin of beans, which is a cylinder, when you peel the label off, it's a rectangle, right? And it's got a height of this, and it's got a length of the circumference of the circle, because you've wrapped it all the way around that can. So this length. And if you multiply those together, so if you find the circumference of the circle and times it by the length, you've got the surface area of that bit that's wrapped around. I always think about it as a tin of beans or spaghetti hoops or something, and you're peeling off the label. That is a rectangle. That's how you print the labels to put it around. So that's how to remember the surface area of that one. And this one in particular, we'll go over a couple of questions on. So hopefully you're all with me so far. I don't think anything's on the chat or Q&A yet, so hopefully that means you're all following. So we've just got two more, so stick with it, and then we'll do some questions. So the next one that we're going to go over is a sphere. So a sphere is like a football or a globe. It's not like a prism. It's not a shape that you've extended. It's its own kind of shape. And it's the hardest one for me to actually draw. Gosh, I actually don't even know how to go about drawing a sphere, because it's a ball. Guess I just kind of have to draw it like that, really, and put shading on it. I think I'm going to make it worse if I try anything other than that. Just imagine this is 3D. We've got the radius of a sphere, just like you do of a circle, but it's from the center point. So if you imagine you've got a ball and there's a center point right in the middle, it's from that to the edge. So from wherever the middle is to wherever the edge is, that's the radius. And then we've got a couple of formulae for this. So I haven't got the surface area one written down, so let me just grab that up. Okay, so we're not going to be doing any proofs of why these are the formulae. There are some cool proofs out there, so feel free to Google it if you're someone like me who likes to know where things come from. It's a bit above what we're covering today, unfortunately, so you will just have to take my word for it. But the volume is 4/3 of pi r cubed. Looks kind of horrible, but it's not really. It's just plugging in things that we know. 4/3 is just a number. Pi, just a number. And then we've got r, we just cube that. Multiply them all together. And there you go. And don't worry, we'll do some examples with real numbers of these. The surface area is 4 pi r squared. There's no real way of kind of memorizing these. You might get given them in an exam on the formula sheet. But I guess just, yeah, you'll just get used to using them and stuff. So spheres are actually really, really easy to work with because once you've got the radius, you just plug it into one of these formulas and your calculator tells you the volume and the surface area. So spheres, unlike what they seem like, are actually one of the easiest shapes to work with that we've done. This is just a formula to whack it into. So then finally, let's have a look at a cone. So a cone, it's like a party hat or perhaps a traffic cone. It's got a kind of circular base and then it comes up like this. So I guess you should think about this line at the back more like this, because that's through it. So sorry, I'm just getting the formulas up for these as well. See, they're hard to remember. So again, these are two formulas that we just have to memorize. Now the volume for both of them, in fact, we need both the radius of this circle at the bottom, which we'll again denote as r, and then the height. Now the height we measure from the center point here up to the peak, and we'll call that h for height. So these are the two measurements you've got to know for these formulae. Then the volume is 1/3. I get confused between sphere and cone sometimes. 1/3 of pi r squared h. So again, looks confusing, but 1/3 and pi are just numbers. R squared and h, well, once you've got r and h, it's very easy to plug in these things. Now, the surface area of a cone is interesting because you've got to think, first of all, about the circle on the bottom. Well, that's easy enough. That's pi r squared. That's just the surface area of that circle. But then we've got to think about the surface area of this bit that comes round, that kind of, yeah, the other bit that's not the circle on the bottom. And again, it's just another formula that we've got to learn. But for this, we need one more measurement, which is this here, which we're going to call L, which is the sloping length of the cone. So we only need that for the area. So without that, you can nicely work out the volume. But for the area, that bit is pi RL. So see, you also don't need H for the area. So you need R for both of them. H tells you the volume, L tells you the area. And these are just things that you've got to learn, really. And hopefully that will make sense. Yeah, so these are just things that you've got to plug in, knowing different lengths. And yeah, this L is called the slant height. And yeah, as someone's pointed out, you can work out L with Pythagoras if you know H, and vice versa. Yeah, that's very true, because we formed, and we'll have a look at this in some questions, we formed a kind of triangle here. And we know this is a right angle if the peak is directly above the center. So then that works, yeah. But we'll have a look at that in some questions. So key things that you need to remember or have written down from today: this thing about the prism, that is the area times L, these formulas for spheres, and these formulas for cones. And now we'll get into some questions. So first of all, does that all make sense? Everything that we've gone over there. Just let me know in the chat if there's anything that you want me to revisit. And if not, I'll be using my trusty website, Maths Made Easy. Now this page here has got loads of stuff. So exam style questions are a mix, perimeter, area and volume, just area and volume questions, and then specific ones on cylinder and prisms. So we're just going to have a look at the generic one to start with. And I've got some surface area ones as well that we'll go over. So let's have a go at this one because it's a bit of a word question as well. So in this question, the diagram shows two boxes. Pete says that 125 of the smaller boxes will fit inside the larger box. Is Pete right? You must show your working. So does anybody have any ideas on how to do this? Just let me know in the chat if you do. Okay, I'll go over this one then. So if we work out the volume of this box and see if and the volume of this box and see if 125 times this fits into that, then we'll know. Yeah, perfect. In fact, Daniel said, find the volume for each. And if the volume of the smaller box can divide the one for the bigger one 125 times, and he's right. That's perfect wording. Yeah, exactly right. So let's find the volume for each. So they're just boxes, they're cuboids, so it's nice and easy. So the first thing that we'll do is with this one here, 30 times 20 times 25. Now this would be a calculator question, so I'm going to go ahead and use my calculator for this. So 30 times 20 times 25 is 15,000. And remember the units even when you're doing your working so that you have it clear in your head what you're doing. So the volume of the bigger box is 15,000 centimeters cubed. The volume of the smaller box is 4 times 5 times 6, which is 120 centimeters cubed. So what I'm going to do is divide it to see how many would fit. Rather than like specifically checking 125, I'm just going to do 15,000 divided by 120 and have a look. Well, that gives us exactly 125. The thing that we have to check now is that those shapes of boxes would actually fit in. So yes, in theory, everything, you know, if you filled 125 of these with water and poured them in, you would exactly find that. But can we, you know, if this box was a really long, thin box, like they might not be able to fit in that exactly. There might be kind of a gap of room at the end, if that makes sense. Now, I don't know personally if there's a real process for thinking about this, but I would say the way that I could tell is that this box is this one, but scaled up by 5. Can you see that? Because 6 times 5 is 30, 4 times 5 is 20, and 5 times 5 is 25. And because it's scaled up, they're going to fit exactly in there. And the reason that it's 125 is because it's scaled up by 5, and 125 is 5 cubed. So the additional thing that you have to write here is something along the lines of, because the larger box is a scaled version of the smaller box, the smaller boxes will exactly fit in 125 times. Therefore, Pete is right. So you would get most of the marks for doing these calculations of volume and stuff, but you do have to check this because it's so precise. You've got to be sure that there's not going to be any leftover room. You know, when you're trying to fit something in a box and there's a bit of room down the side and you're like, oh, if I smushed this, I could. So you've just got to be careful with that. So hopefully that will make sense. Let's have a look at another. Okay, we're going to do both of these. First of all, this one here. So this diagram shows a tube, so a cylinder. So we want to calculate the volume of the tube. So I'll give you guys a couple of minutes, have a go at doing that. And just pop it on the chat or the Q&A, tell me what you get. Or if you can't do the whole thing, tell me how far you get and we'll see. Because I don't know the answers for these, I won't be able to tell you if you're right this time, but just let me know and then we'll see if it's right when we actually go through it. So yeah, I'll give you a couple of minutes for that, but just shout if you need a hand. So I've got a rough answer, so I'll let you know whether it's close to my rough one without a proper calculator. So I'll just give you one more minute for that to let other people respond. Okay, I don't think anyone else is responding, so I'll go ahead and go through this one. So the volume of the tube, and whilst I'm showing this, if you already found the volume, find the surface area, and I'll go through that as well. Even if you're not sending the answers, give it a go at finding it and see if it's right. So first thing that we do is calculate the volume. So remember, this is just like a circular prism. So we're going to do the area of this. So that's pi r squared. So that's pi times 7 squared, or 49 pi. I'm just leaving it as 49 pi for now so that I can put the final thing into my calculator in one go. And then we times that by the length that this thing is. So it's 49 pi times 15. And that, 49 times 15 is 735. So I just pop 735 pi into my calculator. Now, if you don't have one on you, as I've mentioned before, this one on Desmos is really good. So desmos.com/scientific, because it works just like a calculator. It can store your answer and stuff like that. So I would really recommend it. So there you go, 2,309.0706, or let's just say 0.07. Or if we just round it to 4 sig figs, 2309. Which those who answered got, so that's fantastic. Now, has anyone had a go at the surface area? Someone asked, can you save variables in this Desmos calculator? That's a very good question, actually. Gosh, possibly. I know that it saves your answer. Let's have a quick look. If I try saving something. No, I think that's just literally typing. I'm not 100% sure if you can, so it's not as good as a normal calculator, but it does pretty much everything else. Yeah, so I don't think you can actually save values, but you can use answer and it brings up what you had before, so it is useful. Anyway, I'll go through the surface area now as well of this tube. We'll go through this one on this side. So remember, we've got 3 faces to think about. Although it says tube, which does imply that it's hollow, but we're going to call it a closed tube. So we've got, and we're going to find it in terms of pi. So we've got this face and an identical one on the back. Well, we've already said that the area of each of those is 49 pi. So we've got 2 of those. So 98 pi. And then we've got to think about this bit that curves round, the bit that I would call the label of it. So remember, we want to find the circumference and times it by that length. So the circumference is going to be pi d, or 14 pi. Because the radius is 7, so the diameter is 14. Hopefully that makes sense. So then the actual surface area of that bit is going to be 15 times 14 pi, which is 210 pi. So then we add up the whole thing. The whole surface area is 98 pi plus 210 pi, which is 308 pi, if you want it in terms of pi, or as an exact answer, 967.6. So we'll go 968. Oops. 968 centimeters squared. So remember to get those units the right way round. So there's our volume in centimeters cubed and our surface area in centimeters squared. So hopefully those ones make sense. And again, people in the chat got that, which is fantastic. So let's have a look at the, oops, didn't mean to do that. Let's have a look at this one here. So this diagram shows a tube of volume 112 centimeters cubed, and we want to find the height. So a bit different now. We're not looking for the volume, we've been given that, but we want to know what the height would have been to give us that. So does anybody have any ideas about how we can work this one out? Whilst you're having a think about that, I'm just going to open up another question that I want to do in a moment. Cool, I'll grab one from there in a sec. Yeah, perfect. So someone said form an equation, and given the right equation, which is fantastic. So we think about what the volume would have been if we call this h for the height of the tube. Now, how would we have calculated that volume? Well, we would have done pi r squared, so 16 pi, because r is 4, that squared is 16. So pi r squared times h, and then that's going to be equal to the volume that we get out of it. And now, you see the only unknown here is h. So to find h, we can do 112 divided by 16 pi. Which is 2.228. 2.228, and this will be centimeters because it's a height. So it's really important to think, is this thing one-dimensional or two-dimensional or three-dimensional? Because that depends whether it's centimeters, centimeters squared, centimeters cubed, so on and so forth. So well done, people got that really well. Okay, so I want to go through a kind of challenge question type thing now. And that is about something called a frustum. Now, a frustum sounds weird. It's quite a satisfying word to say. We'd highly encourage saying it out loud. Is a cone with a bit chopped off. So it looks like this. Oh gosh, she says confidently. Oh my gosh, it looks like a volcano. I never thought about that. There you go, it's a volcano, but it's a cone and we've kind of chopped the top off. I think there was a much nicer picture of one on here actually. Look, there you go. You can kind of see where this peak was, but like it's gone, so you just have this frustum shape. So yeah, sometimes we got questions about these. For example, let's do this one. So a cone with a height of 35 centimeters has had part of the shape removed. So it was originally a 35 centimeters and it's left this frustum below with these bits here. And we want to calculate the volume of this bit that's left. So does anybody have any ideas about how we could do this one? Perfect, yeah, Daniel's got it in the chat. So you can do the area of the whole cone minus the area of the small cone that's been cut off. Perfect. And whenever you've got a weird shape to figure out the area or the volume of, I'd really encourage you to think about it in this way. Can I do a bigger area or volume and subtract a smaller one to see what I'm left with? Yeah, hopefully that makes sense as to how to think about that. Okay, so the area of the large cone, let's do that one first. Well, we know that it originally had a height of 35 centimeters, so h was 35, and we can see here that the radius is 7. So we just recall the formula that we had for that volume, which is this, 1/3 of pi r squared h. So we do 1/3 of pi r squared h. And I'm just going to leave this in terms of pi. I'd really encourage you to do that. Leave everything in terms of pi until the very last moment so that you can just put one thing in your calculator and cut it to the number of decimal places that you need. It's much easier to do that than have horrible loads of decimal places floating around. So for example, here I'm just going to do 1/3 times 7 squared times 35. So 1/3 times 7 squared times 35. Aha, I still get some horrible decimals, don't I? But I could put it as a fraction. 1715 over 3. So we've got that. That's the area of the large cone. Now let's think about the smaller cone. Well, if the original height was 35 and the height of the bit that's left is 15, the height of this top cone that we can imagine in here, oh, that was bad. That was a very wonky drawing there. Has got to be 20. It's got to be the remaining bit. And we're given here that the radius of that bit is 4. So let's do exactly the same thing. 1/3 of pi r h. Sorry, r squared h. And again, I'm going to do the same thing. I'm not going to include pi yet. I'm going to keep it in terms of pi. So 1/3 times 16 times 20. So 1/3 times 16 times 20. And that gives me 320 over 3 pi. And then, exactly like Daniel said, we're going to take the large one and remove the second one. And that will leave us with the frustum. So 1715 over 3 minus 320 over 3. So now you see this is much easier to do here. So 1715 over 3 minus 320 over 3. See, now we've got an exact answer. We know that this is going to be exactly 465 pi. So the volume of this frustum is 465 pi. And now you see we can really easily pop that. And it said 2 decimal places, so it'll be 1460.84. Remember our units, it's a volume, so it's going to be meters cubed. And there's our final answer. So that's an example of quite a tricky one there to go through. Okay, so we're going to hop back onto the final Kahoot now. We've got 15 minutes to go. And with each question here, unless it's like 100%, I'll go through the question so that we can see how we did it there. So let's find it. Quiz number 2. These should hopefully be the same level of difficulty or maybe slightly harder just so that you can test your knowledge. Stretch it. But we'll give it a go. Oh gosh, it's going to play the music again. I don't know if you guys can hear the music, but I can, so it's frustrating. Oh, I think I could have stopped it there. Oh well. Cool. So go ahead and join this Kahoot. Same thing, either on Kahoot.it or the Kahoot app. There's slightly fewer of you than there were before. People clearly don't like volumes of shapes. We've got 2 square roots and -1 this time. Someone stole it. Okay. Let me know if anyone else is joined. There you go. Well, gang member 4 this time. Did we have 4 earlier? Okay. Is anybody else waiting to join or shall I get started? Okay, I think I'll get started with this one. So 5 questions again, as I said, slightly trickier, hopefully around the same level, we'll see. So the first one, it's a volume of this shape. So we've got a triangular prism. So think about how we did it before and give it a go. Perfect, well done. So let's take this one and see how we did it. So first of all, we want to find the area of this kind of side triangle here that's then been stretched through. So the area of a triangle is half base times height. So half base height. You see how this is the base here and this 2 is the height here. So that's 5. And then we times that by the length here of 8. So 5 times 8 gives us 40 centimeters cubed. Which most of you got, which is fantastic. So well done. Okay. Next one. What's the volume of this shape? So we've got kind of 2 cuboids joined together here. Perfect. 100% on that one. Well done. So I won't bother annotating this, but it's 2 times 2 times 5, and we add it to 2 times 2 times 7, which gives us 48. And well done. None of you were caught out by centimeters squared. So well done on all choosing the correct units there. Okay, what is the volume of this shape? So this cylinder here. So you'll need your calculators for this one. I'll just let the timer go down because it's almost there. Okay, nice, well done. Oh, one of the people has clearly dropped out. So I'll quickly go through this just for the benefit of people rewatching on YouTube or anything like that. So remember, we treat a cylinder just like a prism. So the first thing that we do is that we find the area of this circle, which we know has a radius of 4. So it's pi r squared, or 16 pi. And then we multiply that by the length, so 10. So 16 pi times 10 gives us 160 pi, which then if we pop into our calculator, 502.65, which is the correct answer here, or 0.66. Oh, it should actually be 0.65. So whoever made this actually did a rounding error, but you know, it happens. Okie doke. And the penultimate question, question 4. What's the volume of this shape? So we didn't actually do a practice of a sphere, but do you remember the formula for it? If you don't, just shout on the chat and I can quickly go back to the slide so that you can have a go at it. Now this is one where you've definitely got to put it into your calculator in one go, because look how close together those solutions are. So we don't want to make any rounding errors here. Okay. Has everyone did it? Yeah, really well done, guys. Nice. So, okay, I was struggling to draw a sphere. This is clearly the way to do it with the circle in the middle. That makes sense. So we just need to remember the formula for the volume of this is 4/3 of pi r cubed. So r is 9 centimeters. It even tells us that r is 9 here. So we do 4/3, multiply it by pi, multiply it by 9 cubed. So I'm just going to write it into my calculator exactly like this. 4/3 times pi times 9 cubed. And then we can see here when we round it, 3053.63. So that's why that's what it was on here, which you all got, which is fantastic. So, final question. We want to find the volume of this solid here. So this one's a cone, again in inches, but see if you can remember the formula for the volume there and see what you get. Tricky one, this, because there is an extra step to it. Okay, a tricky one that, as I expected it might be, but well done, because a couple of you got that. So this is the hardest question that we've had on either of the Kahoots. So first thing that we remember is the formula, which is that the volume is 1/3 pi r squared h, where h is this bit here. So here's where we had to use Pythagoras, as somebody suggested earlier. So we know that h squared is going to be 10 squared minus 6 squared. And so 8 works out to be 8. And then we can just plug everything in. So V is 1/3 times pi times 6 squared times 8. 6 squared because R is 6, and 8 because we've just found out that H is 8. And then we can just pop this whole thing onto our calculator. So 1/3 times pi times 6 squared times 8, 301.59. Which is not what the answer was on there. Have I done something wrong? If anybody knows what I've done wrong, do let me know. Oh, someone else said that they got that as well. Oh, have I chosen another question where the original Kahoot creator has put it on wrong? Okay, we'll ignore that question then. I'm pretty sure that this is the correct answer here. So apologies about that one. Let's see these now slightly skewed results. So the podium, well done. Lilac in 3rd. And square root of -1 equals I in 2nd. And with 5 out of 5, which is a lucky guess on the final one, seeing it was wrong, square root of -1. So yeah, really, really well done. And we can see, even with that last question, it was a really, really well answered quiz, 75%, probably the best one that we've had in any of these. So yeah, well done, everybody. So now I think we've got like 3 minutes left, and Bola wants to say something at the end.
Hello, good afternoon, guys. Thank you, Molly. I hope you're all doing well. As some of you already know, this week is the last week of the large group tutorials, also known as the drop-ins, which brings us to the end of these tutorials on the online school. Thank you all for joining us week after week, and a massive thanks to Molly, our tutor, who's been amazing throughout this whole kind of period of time. I'm sure, as I'm sure all of you will agree, Molly has been a great tutor. She's put in a lot of time and effort into the lessons that she's delivered, and she's certainly helped my maths. How much she's helped you guys. So thank you very much, Molly. We do appreciate your effort. And thank you all for joining us. As you all know, you can also continue to access one-on-one tuition via our website, and there are still some small group tutorials that you can join into, which aren't the same as these large group tutorials. They're just smaller groups made up of about 6 students or so, very personalized. You can find out a bit more about those on our site. I'll leave it to you now, Molly. Thank you very much.
Cool. So thank you guys all for coming again and again. You've all been fantastic, and it's been really fun. I feel like I know you guys. So as a final maths joke, I've just quickly looked for some. I'll tell you a couple from this page, seeing as we have a final one. What did one angle say when flirting with the other angle? You are a cute angle. This one's an image, right? I'm going to share this one. Here you go. And this guy just goes on forever because pi is irrational, so it goes on forever. So there you go. We'll finish with an image joke, which we've never had before. Thank you all for coming week after week. I've really enjoyed it, and I've really liked interacting with all of you guys. So good luck with your results, which I know are soon. Sorry to bring that up, scary thought. But you're all going to smash it. And yeah, thank you for making my lockdown much more interesting. So hopefully I'll see some of you in the tutoring world at some time soon. Bye-bye.